Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be discussing electrolytes. Now, we want to discuss electrolytes because this is going to eventually lead into net ionic equations, which is going to be a few videos from this one. But to get us started, we need to talk about how things dissolve in water. And we know that table salt, if we were to sprinkle it in some water, that it would dissolve. So we have some ionic compounds that do dissolve in water and some that do not, okay? Table salt is one of those ionic compounds that we know dissolves in water. So when it's put into water, when we have solid sodium chloride dissolve in water, something special happens, okay? The ions, okay, are actually going to separate in the water. And it's going to form sodium ions and chloride ions. We call this a strong electrolyte. So anything that splits up 100% is what we call a strong electrolyte. If we looked at a particulate diagram and I had a beaker of water right here, we would have no sodium chloride together. Instead, for every one sodium ion, there would be a chloride ion. Okay? And if we have another sodium ion, then there would be another chloride ion in this 1-to-1 ratio. But there would be no sodium chloride that's together. And that's because this is a strong electrolyte, and strong electrolytes split up 100%. So if I was to stick a conductivity meter into the solution of sodium chloride, it would conduct electricity because of all of these now mobile ions just floating around in solution. Now, sugar is not like that. It does dissolve in water. We've made Kool-Aid or other flavored drinks with sugar in it. It does dissolve in water. However, because it's a molecular compound and it's not ionic, so there's no positive ions or negative ions in here, it's a covalent compound. It's a polar covalent compound. It will dissolve in water, okay, but it does not split up. And that's because there's no ions. Because this is molecular and not ionic, it can't make ions. Okay, so we call this a non-electrolyte. And if we had a particulate diagram of this, okay, as we put the solid sugar into the water, it will dissolve, and now it's aqueous, just like these guys should be aqueous as well, okay? So now when we dissolve it in water, it's going to be the whole molecule. Nothing splits up in a non-electrolyte. And the reason why I know this is a non-electrolyte, okay, is because it's covalent, okay? Now it is polar covalent, so it will dissolve in the polar water. But for every molecule of sugar that you have as a solid, will now be dissolved in the water. And if I stick a conductivity meter in here, it will not conduct electricity because there's no ions. There's no mobile ions with a non-electrolyte. Okay, so this is kind of like on one end of the spectrum, and this is on the other end of the spectrum. Somewhere in the middle, we have something called weak electrolytes. Okay, and this is going to be your weak acids and your weak bases. In this example, I have hydrofluoric acid, okay? And when it dissolves in the water, we're going to use what we call an equilibrium arrow, okay? Which means that it splits up a little bit into its ions. So if we were doing a particulate diagram of this weak electrolyte, it would look something like this. Here's my beaker of water, okay? And you're going to end up getting a whole bunch of HFs, okay? And then every once in a while, you're going to get it split up into its ions. And that's because this reaction works in the forward direction as a decomposition reaction, and then in the reverse direction, kind of like as a synthesis, two things coming together to make something bigger, okay? Now, with weak acids and weak bases, because I've been doing chemistry for a really long time, I know how this is going to break up, okay? For majority of your weak acids and weak bases, it works something like this. Approximately 1 or 2% of the time, it's going to split up into its ions, but a majority, like 99, 98% of the time, it's going to be a molecule as a whole. So in my particulate diagram, a whole molecule, a whole molecule, a whole molecule, and then once in a while, we get our ions. Now, we do have some mobile ions here, so if I did stick a conductivity meter in here, it would conduct electricity, but not nearly as well as a strong electrolyte, where over here, we're getting this 100%, and we have really nothing that's sodium chloride together with a strong electrolyte. It splits up 100% of the time. Non-electrolyte never splits up, and in a weak electrolyte, it splits up a little bit, okay? A majority of the time, the weak acids and weak bases are going to be together as a molecule, and then a little bit of sprinkling in of the ions in general. So this is how we do strong electrolytes, non-electrolytes, and weak electrolytes. This is going to lead us into a discussion on if something's soluble or insoluble, and then eventually we're going to use both of these things to do net ionic equations. I hope this helped, okay? And if you did like this video, give it a like, subscribe, and a comment.